Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. For those of you who don't know who I am, my name is Imran Tabrizi. I work in emergency medicine. I work in the A&E department. And before I say anything else, I would like to first of all thank Zahid and his wife, Nolly, for inviting me all the way from London to come here. And thanks for putting on such an excellent show. Has everybody enjoyed it so far? Yeah. Excellent stuff. Brilliant. Okay, so basically what happened was I have been doing medicine, working in the emergency department for the last 12 years. And myself and a friend of mine, Dr. Mark Tan, who can't be with us today, we both worked in emergency medicine, and we both share the same common viewpoint about medicine. And the viewpoint we have is that one of the things that we were frustrated with the fact that a lot of patients would come into the emergency department and they would be on a whole host of medications. They would be on an anti-blood pressure pill. They would be on an anti-cholesterol pill. They'd be on an anti-diabetic pill. They'd be on a proton pump inhibitor. They'd be on a headache pill. The list goes on. Is there anybody, just a show of hands, of anybody who knows people or who are taking that many medications? A show of hands. Okay, so there's quite a few. Well, no, it's not that much actually. I would have expected a lot more. But in the Western world, it's very common. And it's something which is very prevalent in the emergency department. We get a lot of people with chronic illness. So myself and Mark Tan feel that we're losing the battle against chronic medicine. Acute medicine, I think there is, we work in the emergency department, so we deal with that. But chronic medicine, I think we're losing the battle, and I think it's something that needs to change. So what myself and Mark Tan decided to do is we both decided to embark on a course in naturopathy and nutrition. And last year, actually two weeks ago, I actually just graduated. So I'm actually, thank you very much. Thank you. So I've actually seen both sides. I've seen the allopathic side, and I've seen the other side, which is nutritional side, and it's becoming more and more prevalent as time goes on. People are beginning to realize that nutrition is one of the key issues to trying to live a healthy life. So nowadays what happens is that you have people now who are recognizing that. And one of the developments that has happened recently is there is something called functional medicine. I don't know if anybody's heard of that. But functional medicine is something which is growing. There is, in the United States, in Washington State, there is the Institute of Functional Medicine. And last month, I attended one of the very first international forums. And our next international forum is going to be in April. So I'd urge you to go on YouTube and type in Functional Medicine International Forum. And I think it's something which, as you get involved with Kangen water, it's going to be something that you're going to want to know more about. You see? And the reason why I say that is because how I got into Kangen water was through Mark. And through discovering Kangen water, it has taught me a huge amount about water that I never knew. And I think most of the people in this room who've experienced Kangen water also will be surprised at this great gift that Allah has given us, which is the water. And I think most of the people in this room are very privileged, in fact, to know or to be in touch with Kangen water. Most of you have seen the lectures or the demos about all the places where they have this miracle water. You've heard about Lourdes in France. You've heard about Lake Titicaca in Peru. We have Zamzam water. All of these waters claim to have miraculous effects, and we now know with science what it is, or some of the attributes of what Kangen water has. Now, Coming back to what I said about functional medicine is something which is slowly being picked up. It's something which is only a handful of doctors actually recognize it. And it's hoped that this community will start to grow. Can you hear me all right? Yeah. So it's a community which is slowly growing, and as time goes on, people are going to start to realize that a lot of the things that we eat and drink is what determines how we can become more healthy. And it's a very good way of looking at things. One of the sayings we have is, فَبِأَيِّ اللَّهِ رَبِّكَ مَا تَكَذِبَانِ. Which of the favors of your Lord do you deny? Allah has created your body. He's created all the things that you could possibly have in the world that grows, which you have access to. Zamzam water being one of them, and alhamdulillah, Kangen water is now with us. We have that. We have that. Vegetables and fruits. Vegetables and fruits is something which grows. Allah has provided that for you, but yet we deny. Not only do we also deny, we've complicated things even more by actually poisoning them. Now, the reason for that is because of supply and demand. When you start to introduce ecology, economy, and politics and all of those things, people want to make profit, people want to make a large amount, it suffers from those things. So vegetables and fruits now have a lot of pesticides in, insecticides in, but alhamdulillah, we now have a way of removing that. We have Kangen water 11.5. We can put that inside. We can wash vegetables and fruits. What does Kangen mean? Back to origin. So you can see the beauty of the water. Kangen means back to origin. So what it's doing, it's taking your vegetables and fruits back to origin, back to the way it was intended to be taken. Fresh, without pesticides, free of all of those kind of things which would poison your inside body. So this is such a powerful thing, and we should be privileged to have this. So what I endeavor to do next is to try and take you through a journey to understand what it is. We heard a lecturer earlier on talk about know your product. That's what I want to try and impart with to you guys. Having a deep understanding of what it is you really have, how powerful it is. Now, before we say that, the other thing I'd like to mention is that there is a lot of conflict in the scientific community. And as people promoting Kangen water, you're going to come across situations where people are going to ask you questions like, why aren't there any studies to back up why Kangen water is so great? Is that a question that you've had to come across? So what do you say to them? Exactly, what do you say to them? Well, the thing is, what you have to understand is that medicine itself has also suffered the same fate as vegetables and fruits. It's been muddied, the waters have been muddied by politics, it's been muddied by capitalism to a certain extent, and what happens is, and also law. And these are the things that have taken medicine to a different level. In all my lectures, I always say, who is the father of medicine? Who is the father of medicine? Hippocrates? Not Socrates, no, Hippocrates. Socrates was the guy who did the 90-degree angle thing. Yeah, Hippocrates. Now, Hippocrates used to say, let thy food be thy medicine, let thy medicine be thy food. Now, I would have to say that the compass heading in medicine has changed direction drastically. We don't follow that rule anymore. We rely on medications, we rely on surgery. Now, I'm not saying that these things are bad, but what I'm saying is that moderation is the key. And we have to embrace this knowledge about taking responsibility for ourselves, drinking the right water, which you now have, the best, and eating the right food in the right consistency and pesticide-free. So, where is the conflict in this medicine? The conflict comes when it talks about research. Research is something which medicine depends on in order to justify why you go in a certain direction. For instance, we rely on something called evidence-based medicine. Now, what is evidence-based medicine? Evidence-based medicine is where you have a situation where you put something through a trial. So, for example, we have a room full of people, you have a medication, you split the room up in half, you give half the people this medication and half the people a control. And you compare to see whether that medication has had the desired effect. And if it does, with the majority of people, they will pass it and say, yeah, this medication, we endorse this, this is it, this is what we're going to start using. And that, unfortunately, or fortunately, whichever way you look at it, has been the way in which illnesses have been treated or have been dealt with. So, a pill for an ill. So you have, for example, metformin, which is the drug for diabetes. You have proton pump inhibitor lansoprazole with people who have acid reflux. And this is the way in which we follow. And nobody would argue with that. Nobody would say that that's wrong because it's evidence-based. We've seen it work. But the problem here is that everybody's different. Every human being is biochemically different. And you're going to learn more and more about that. You're going to see a lot of these new products coming out. For example, something called 23. Has anybody heard of 23andMe? Yeah, so these are all genetic testing kits, which you can take home, send off to a laboratory, and they will send you back a biochemical pathway or a biochemical system to show how you fare or how your body does things like oxidizes, if you're a fast oxidizer or you're a slow oxidizer, how your body is different from everybody else's. And that is something which is new. That is where medicine's going. And this is why nutrition fits in with that. Because now what we can do is we can look at the biochemical pathways and try to supplement. So for example, if you're deficient in a certain nutrient, you can then harness that nutrient. But then it depends on where the source of that nutrient comes from. Because now you have the problem with supplements. You have different types. You have supplements which do nothing. You have supplements which have been tried and tested. And that's why you need to go and see a nutritional therapist, because they usually will know which supplements are tried and tested and which ones work. So that's another sort of way of looking at how the body is and how we need to go down that pathway. Now, the other thing to mention is the next conflict, which is when it comes to talking about Kangen water itself. Now, does anybody know how to deal with conflict? So in Islam, how do we deal with conflict? So there is a surah in the Quran that says, let me get this right. It says, Khul. Let me get it. I better take it out because I'm going to keep forgetting it. I always keep forgetting. Let me get it right. Let me say this properly. All right. It's probably because I'm a bit nervous. That's why I keep forgetting. Yeah. All right. I don't want to say it wrong. Okay. So it's Khul ya ahlal kitabi. That means say, O people of the scriptures, Ta'alaw illa kalamati sawa'im baynana wa baynakum a'la na'budu illallah. That means come to words which are equitable or equitable between you and I, so that we may go forth and pray to no one except Allah. Essentially, what that is trying to tell us is that we need to come to common terms between you and I in order for us to move forward. How do you come to common terms in a situation where people are relying on evidence-based medicine and trying to ask you about Kangen water? How do you deal with that? So the title of this lecture originally was The Science of Kangen Water. But I wasn't happy with that. I wanted something a bit more, I wanted to define it. And that's why we called it Molecular Hydration of Kangen water and its application at the cellular level. Why did I choose those words? Because that is how I wish to come to common terms. How do you come to common terms? You have to take things down to the cellular and molecular level. Because people can't argue with that. It's been tried and tested. People know about atoms, protons, electrons, neutrons. At least that's what you guys are going to learn. So I apologize to all of those unreservedly if this is something you find boring. But I think it's important because we have to go with what our lecturer said earlier. You have to know your product inside out. And these are questions that people are going to want to know. We've heard some testimonials, some very heartfelt testimonials about somebody who had SLE. We've heard some other testimonials about people who have cancer. We've heard some other testimonials about people with diabetes. But the question is, why is it that Kangen water is helping these people? Now, as a medical doctor, I am not at liberty to make any statements about what this Kangen water can do. I'm not allowed to do that. I'm not allowed to make any, some wild, miraculous things that Kangen water does. But what I can do is I can explain at the cellular and molecular level how it is that these testimonials are actually happening. Why is it that these people are actually benefiting from Kangen water? And that's what I hope to try and achieve today. Because once you understand what it is that Kangen water is and how it works at the cellular level, you will be able to answer some of those questions. Okay? So, what we're going to do first of all is we'll go right into it. So, apologies again. What is water? What is a chemical symbol for water? H2O. So we have H2O. Now, is water H2O, really? Is it just water? Is it just H2O? Is that water? Is that what water is? No. So water is a medium which contains a lot of other elements. We have sodium, potassium, calcium, magnesium. Somebody's going to put up a periodic table at some point. But anyway, all of those are in the water. Okay? Now, but let's, for simplicity, we'll just deal with this, H2O. Now, H2O can actually go to H plus OH minus. So this is what is called a dissociation. So water usually looks like this. You have the oxygen and you have your two hydrogens. Some of you probably have already seen this by some other prominent lecturers on YouTube, including myself. Anyway, so you have H2O, which goes to H plus OH minus. And that is called a dissociation, and it goes back the other way. That's why the arrow is written in both ways. Now, what we need to understand is we need to understand the difference between this, and this. This is half the battle. A lot of people don't seem to get this right. And I've seen people make mistakes on YouTube when they talk about this stuff. So this is why I want to make sure that after you leave this lecture, you all understand what it is we're dealing with. And you can tell all your friends. So, right, okay, periodic table, right. So in the top left-hand corner, you have the very first atom, or the very first element, which is hydrogen. Yes? H has an atomic number of 1. Now, every atom contains what three things? Or most atoms? Neutrons, protons, electrons, right. How many neutrons does hydrogen have? You sure? Final answer? Hydrogen contains 0 neutrons. Yeah, that's a trick question. You fell for it. Right. So it has 0 neutrons. Okay? How many protons? 1 proton. And how many electrons? I'm talking about hydrogen, yeah? 1 electron. Now the reason why hydrogen, this is hydrogen atom, this is what we're talking about here, hydrogen. Hydrogen has 1 proton, 1 electron, and therefore the proton is the positive charge, the electron is the negative charge. The positive and the negative cancel each other out, so hydrogen atom has a charge of what? 0. 0 charge. There's no charge on hydrogen atom because the electron and the proton cancel each other out. Right? That's that one there, the one that says 1.0079. So that's your hydrogen atom. Yes? So what then is this creature here? What is H plus? Is that an electron, or is that a proton, or is it a hydrogen atom? Which one? It's a proton, right. And that's why, because it has a positive charge. So that's this. This here, hydrogen with a plus, is actually a proton. It has lost its electron. Because the electron is the thing that is on the outside. It's the cloud. The electron has been dropped, and all that's left is a proton. Now, that, ladies and gentlemen, the proton, is what determines what about the liquid? It determines the pH. Well, it determines the acidity of a liquid. So what it means is if you have a lot of these, what is it called? Acid or alkaline? It's an acid. So acid is if you have loads of these. If you don't have many of these, what is it? It's an alkali. Exactly, so that's the difference. Now, so that is the basic premise. This one, H2, is a hydrogen what? It's a hydrogen gas, yeah, but what is it also called? What's the title of this topic? Molecular hydration. It's molecular hydrogen. That's what H2 is, molecular hydrogen. And why is it a molecule? Because it's two atoms. Two atoms make a molecule. So that's what this is, which is a gas, as you rightly said. Now, molecular hydrogen is the magic ingredient in Kangen water. Yeah, that is the secret weapon in Kangen water, H2. Now I can just pack up and go now. That's it. Job done. Right? But that is it. That's the secret ingredient, H2. Now, the next thing we need to do is, what are the three properties of Kangen water? Alkalinization, antioxidation, and microcluster, right. So we're going to deal with each of those in kind. And the reason why I want to deal with those each in kind is because it's important you understand what those things are. So the first thing we're going to deal with is alkalinization or alkalization, whichever way you want to look at it, alkalization, right? And this is determined by something called the pH. Now what is pH? What is pH? Say again? So pH is called potential hydrogen. Well, actually, that's actually a misnomer for two reasons. P is potential. Let's call it potential. P is actually a mathematical term. This P actually means negative logarithmic concentration of. Yeah? Follow me so far? No, you're not. Now you're all looking at that and thinking, what the hell is he talking about? Negative logarithmic constant, what? Basically what it is that, right, what it is, this H here, first of all, this misnomer, this H, does that refer to the hydrogen atom or the proton? You see? This is why it's a misnomer. We already met in the last page, we already talked about H plus and H. And you would be right in thinking that it was H as in hydrogen atom. But for some reason, we decided to drop the plus, and we call it pH. This H actually does not refer to hydrogen atom. It refers to H plus. And that sits in here. Now, because there's a lot of it, a lot of these protons, they had to come up with some way to quantify it. And sitting there going 1, 2, 3, 4, 5, 6, 7 would take them all day. Yes? So what they came up with was this thing called a logarithmic scale. So what they did was they said, now the logarithmic scale works exponentially. It increases like that. That's how it goes. It starts slow and it goes up like that. So this is called a logarithmic scale. And they cause negative logarithmic to confuse you even further. So what that negative means, it flips everything upside down. So what it means is if there's a lot of protons, the number is smaller. If there is less of it, the number is higher. And the scale is between what and what? 1 to 14. Yeah? This means it's acidic. This means it's alkaline. Yeah? So protons, if there's a lot of it, it's acidic. So that's when you come up with pHs of 1, 2.5. Yeah? This is all in the acidic range. Then you come to our favorite, pH 9.5, which is at the other end, and even better, 11.5. Do those waters contain less protons or loads of protons? Less, exactly. So you got it. So basically, this is what we talk about when we talk about pH. pH means negative logarithmic concentration of protons. So if you understand this, then you understand the difference between acid and alkaline. So this covers alkalization. Now, what happens here now is when you go and do your demos, what color is it when it's acidic? What color is it when it's purple? Sorry, no, that's a stupid question. What color is it when it's pH 7? What color is it when it's 8.5? What is it 9.5? Excellent. So you've got a way of distinguishing each of those concentrations of pH. And it's very important because that's going to tell you how well that machine is doing at producing the pHs of the water that you have. And now you know why. So when you put purple in there, you say, oh, that doesn't have that many protons in it. When you see one which has got orange, you say, oh, it's got loads of protons in it. So now you know the difference. Yeah? So this is talking about protons. Right. The next thing we're going to talk about is antioxidation. Now, in order to understand what antioxidation is, we have to understand why is it called anti, and what is it that it's doing? What's so good about antioxidation? And in order to answer that question, we have to know what a free radical is. Does anybody know what a free radical is? And it's not ISIS. Right. Free radicals, can we get the periodic table back up? Right. Zoom out. Excellent. Right. So up there is the periodic table. Are you all familiar with the periodic table? Yeah, you all went to school? Excellent. Right. So what we have here is we have a table. And we have, on the far left, our friend hydrogen, which is in group 1, which is the first column. Now, if we move over to group 8, which is right at the other end, you have all of this column here. They're called noble gases. And if you go one more in, you have group 7, and the top one is fluorine. Yes? And below that is chlorine and all the other enes, bromine, iodine, astatine, and can't spell the last one. Anyway, so these are all group 7. Now, the importance of group 7 elements is that they are the usual suspects when it comes to free radicals. Now, what is a free radical? A free radical is an atom, an ion, or a molecule that has a lot of energy, or it becomes so energetic that it leads to damage. Now, how does it do that? In order to answer that question, we have to go and visit our friend Mr. Bohr. Has anybody heard of the Bohr atom? No. B-O-H-R, Bohr. So, and it's not to be boring, but it's basically to tell you about the atom and try to explain all of this. So what we have is we have an atom which contains, as I said before, neutrons and protons, but then you have the electrons. And what we have is we have the first shell, which contains 2 electrons, which is the first shell around the atom. So I want you to visualize something that looks like planets. Yeah? That's your atom. And the first shell, or the first layer, is this layer here, which has got the 2 electrons. So this particular one here would be referring to helium, which is the one on the far right. Hydrogen has only got 1 electron. Yeah? Is this atom happy? Why not? Because it only has 1 electron, and electrons like to come in pairs. So this hydrogen atom will do what? it will merge with another hydrogen atom to form 2 electrons, and this is H2. You all got that, yeah? All right. So this is molecular hydrogen. This is your hydrogen gas. This is the secret weapon in Kangen water, H2. When 2 hydrogens get together, it's because they're sharing these 2 electrons, you get H2, which is your hydrogen gas. That's why when you have the water coming out of the spout, yes, you go and get your lighter, you hold it by the stream of water as it comes down, and what happens? No, it doesn't blow up. You hear a popping noise, and that's your hydrogen gas. That's the hydrogen gas reacting with the light, and that's H2. That's molecular hydrogen. That's where 2 hydrogen atoms join and form that. Right. Now, well, thanks. Right. So, now, moving on from this, we need to move on to which we started off talking about, which is group 7. Now, group 7 is in the second row, yes? So in the second row, you already have 2 electrons. Now we come on to, well, actually, let's do this on the next page. Right, so we've talked about hydrogen. Let's put hydrogen up here with 1 electron. Now we're going to talk about fluoride, which has got 2 electrons in the first shell, and then in the outer shell, it's going to contain 1, 2, 3, 4, 5, 6, 7. 7 electrons. Is this atom happy? No. Why not? Because it has 1 unpaired electron, which is this one. So this fluoride atom is going to try and grab it off anybody it can get hold of. It really wants that electron. Yes? It's like me, I'm hungry, I go and thief some money off Zahid, he's going to be very upset. So he's going to then take money off somebody else, and he's going to take money off else, and it goes around, and that's what you call a chain reaction. That is what is free radical damage. Yes? So that's essentially how this works. You have a free radical, this becomes the source of a free radical, and it's going to rip electrons off anything it sees. That's why, for example, when we start talking about damage, you get free radical damage to cells. Yeah? And what's happening is, for example, if you want to apply this to something like, for example, patients with high blood pressure. Why do patients have high blood pressure? There's a number of reasons why they have high blood pressure. One of the causes is in the vessels that contain tissue, and tissue is composed of cells, and those cells get damaged. How do they get damaged? The free radicals get in and damage the inside of the cells by doing this, by ripping electrons off other things. And by ripping electrons off, that is called an oxidation or reduction reaction? Oxidation, because oxidation leads to aging, damage, rust. You guys remember the apple? Yes, it goes brown. So that's oxidation. So this is what it's doing. It's trying to rip electrons off to fill that up. Yes, that's fluoride. Chloride, which is the next one down, has another shell. And that contains 1, 2, 3, 4, 5, 6, 7. Has another single. Is that atom happy? No. Why not? Because it has an unpaired electron. So chloride is going to do the same thing. It's going to rip electrons wherever it sees it. That's why chloride basically is causing damage to cells. And somebody decided in their right mind that it would be a good thing to go and stick in water. Yes? And who decided that? Somebody who wanted to try and save people's lives because they felt. So you know about the story about this. This happened in London, of all places, because everything happens in London. There was all these people getting sick. Somebody from number 22 was getting sick. Somebody from number 28 was getting sick. Somebody from 42. This guy, he looked and he said, why are all these people getting sick? So then he decided, he looked, and in those days, they all used to share water from the well. So you go to the center of the well, there's a well there, so he went there, took a sample of water, looked at it under a microscope, and what did he find? Bacteria. So he thought it would be a good idea. He says, I know what, we need to come up with something we can put in the water that's going to kill the bugs, but not necessarily going to kill the people. I know, we'll stick chlorine in. And that's how Chlorine has been added to water. That's why we drink it. They pass it through government, and that's why we add chlorine into our waters to try and kill all the bugs. But what is it doing to you guys? Nobody asked that question. Because by the time you pass away, nobody cares. Yeah? So this is what it is, chlorine. Chlorine in the water. Now, so chlorine is also a source of free radicals, as is fluoride. So this is a free radical. Now, how are you going to make this guy happy? You're going to have to give it something. Now this comes on to what I say at all my lectures, so some of you already know the answer to this. But in what form does the most powerful source of energy exist in? In what form does the most powerful source of energy exist in? Some people say sun, some people say light. Simpler than that. Love. Exactly, love. What is love? Love is the law, power of attraction. Now, what does the law, power of attraction say? It says that if you give love, it has to do what? It has to come back to you. Yeah? If you give love, it has to come back to you. It's not a question of when. It's not a question of if. But what you must not do is expect. Don't expect. You give it freely. Why is that important? Because now we come on to the secret weapon in Kangen, which is molecular hydrogen. Molecular hydrogen contains 2 electrons which they share. Yes? Now this, ladies and gentlemen, is your antioxidant, not OH minus. Now unfortunately there's a Dr. Michael or whoever it is on YouTube who keeps on saying it's OH minus. It's not OH minus, it's active hydrogen is the antioxidant. This splits apart and becomes 2 hydrogen atoms. And why are they hydrogen atoms and not protons? Because they contain their electrons. Now can you see now that if you introduce this to this, it's going to come and insert itself here and shut this up. Yeah? So by donating that electron and uniting with chloride, it's an antioxidant. It's neutralized the free radical. It's prevented the free radical from causing a catastrophe by ripping electrons off everybody else. Can you see the beauty in that? That's what molecular hydrogen is doing. It splits apart. You have all of those little bubbles that you see in the water, those things are going to get inside of you. And when they get inside of you, they're going to neutralize the free radicals inside your body, which you expose yourself to day by day. Yeah? And what sort of free radicals are there? Plastics, toxins, smoke, nicotine, stuff that you smell when you go outside, all the pollution, all of those are sources of free radicals. Water that you have which has chlorine in, which you don't drink anymore because you drink Kangen, which has the chlorine taken out. Yes? So all of these things are going to be neutralized by those same hydrogen atoms which derive from molecular hydrogen. And it's going to neutralize those free radicals. Now, the other one, this is chloride. Fluoride is the one above. Has anybody ever heard anything good about fluoride, apart from the fact that it seals all the stuff in your teeth? No? So fluoride, what does it do? Yeah, it does. But the other thing it does is, they did some studies on about 100 cadavers. And what happened is they looked at these cadavers, they looked at the brains of these cadavers. And what they discovered was where the pineal gland is in the brain, they found that it was corroded. It was completely calcified. And this pineal gland, how it got like that was because of a buildup of fluoride. The fluoride, for some reason, all accumulates in that particular area. And everybody knows that the pineal gland is what's known as the third eye. It's your ability to be able to have insight. It's determined by that gland, the pineal gland in the brain. So you can imagine fluoride causing that problem. And one of the problems we have now is that a lot of water has fluoride in. As a matter of fact, there are some places where it is actually legislation to put fluoride in the water. And in England, we have places where we have hotspots where they actually, by law, have to put fluoride in the water. Thankfully, it's not London, where I live. It's up north. Hey. So, fluoride. So fluoride can actually get deposited in the pineal gland. Now, the other thing that fluoride is, they did another study where they found that the fluoride in the water, most of the people living in that area, they had very low IQs. And they associate that with fluoride. So fluoride doesn't have good press when it comes to those kind of things, but clearly it's very good for your teeth. But hey, good teeth, no brain? I don't know. You work it out. But anyway, so fluoride and chloride. So hydrogen, molecular hydrogen is going to neutralize those things, yes? And that's basically how you get the free radicals. That's the antioxidants. That's the antioxidant story. Now, the other thing I want to clear up about the antioxidant story is this thing about the ORP. Now, what does ORP stand for? Oxidative reduction potential, right, okay. Now, there seems to be another, misunderstanding about what ORP really is. Yeah? Now, ORP, if it's positive, is that good or bad? Bad. And if it's negative, then that tells you that it's got what? It tells you that that liquid has antioxidant properties, exactly. But what is actually ORP? What is it actually measuring? Nobody really knows, do they? Measures what? Electricity. Okay, well, another way of electricity. Okay. So if I go and take that ORP meter and stick it on a wire, is it going to give me a positive reading or a negative reading? Yeah, the jury's out on that one. Okay, ORP is actually measuring a ratio. Now, what is the ratio? The ratio is between this product, or this particular species, and this. Does anybody know how you get from this to this? You should know now, because we talked about it. This is a what? What is this, a proton or electron? What is it? It's a proton, right. What do I have to add to this to make this? What do I have to add to this to make this? An electron, right. So if I add one electron, I get this. So how do I go from this to this? You add another one which has a proton and an electron, and you get that. So if you add 2 electrons and 1 proton, you get this. That's it. That's the difference. Now, the ORP, when it becomes negative, what that means is that there is a lot of this and less of this. Yeah? So do you see now, when you get your pH 9.5, is there a lot of protons or not much? Not much. Not much. When you get your pH 9.5, are there a lot of H2 hydrogen gas bubbles in it or not? So you have a lot of this and little of this, so therefore you have a negative ORP. Yes? You get a negative ORP. If you have a positive ORP, it's the other way around. It means you've got more protons and less H2. So if you go and measure the ORP in your pH 2.5, what is it? Positive or negative? It should be positive, yeah. So this is telling you then that that particular product has antioxidant properties. So that's what the ORP is measuring. ORP is measuring the ratio between molecular hydrogen and its precursor, the proton, which you have to add the 2 electrons through to in order to get the H2. And where does those electrons come from, guys? So, earlier on in the lecture, you heard about energy in the form of something called it's called potential electrode unit, PEU. Yes? You know about PEU? So you take the wattage of the system, you multiply it by the amperage, and you multiply it by the surface area. And as we know, the SD501 has a very, very high PEU. All of that energy goes into that water to produce that active hydrogen. It takes the water, the H2O, and it obliterates that water to produce, well, it produces this. H2O goes to H plus OH minus. Anything else? Plus H2. Those are your byproducts. That is what that energy is doing. This is why you're going to have some machines which don't have enough energy to do that. And they can't produce that enough energy to do it, because if they did, what would happen to the plates? They would melt, because they can't stand up to that. This is why you have medical grade platinum, yes, which is coating the medical grade titanium. Yes, platinum, yeah, that's right. So what you have is you've got a very, very powerful plate which can withstand that heat and that energy, and in so doing, transfers that energy onto the water to produce your active hydrogen from that water, which produces all these byproducts. So you've got OH minus, H plus, and H2. Now, while we're on this subject, the other thing I'd like to do is to clear up this notion about how the electrolysis works. Because I think somebody mentioned my name when they were talking about it, so I feel obliged to talk about that and explain what it is. Now, electrolysis works through a system where you have a positive and the negative. Yeah? Remember this in school? You took one electrode and you put it in one mug or a beaker, and you put the other one in the other. One is positive, one is negative. The posh name for this is cathode and anode. Yes? So this is the negative and this is the positive. Now, how do they separate out? Now, when I look at these diagrams, I always get confused because I don't think it actually explains well what actually is going on, because what you get is you have water. Water is what we're going to throw into this system. So you have your Kangen machine, you have your 7 electrodes all lined up. You have the positive charge on this side, negative charge on that side. So what it means is that all of those ions are going to separate out. So you've got H plus and OH minus. So really, all of the OH minuses should go down the positive one, because this attracts all the OH minuses, because this is the positive electrode. But I noticed that in some diagrams it's flipped around the other way. But anyway, at the end of the day, basically what you have is you have a system where you're separating the water out into acidic water and alkaline water. So you're going to have all the ones with OH minuses, which hardly have any of protons, which is going to produce your 9.5 pH. And then on the other electrode, you're going to have all your protons, yes? And this is going to produce your acid. Yeah? 9.5, and this side should be 4.5, because they both add up to 14. Yeah? So you have this acid on this side, so this is the lower spout, and this one is the upper spout. Theoretically, that's how should this work. Now, when you want to make 11.5, pH 11.5, you have to add what? Enhancer. And what does that enhancer contain? Sodium hypochlorite and sodium chloride, exactly. And sodium hypochlorite is 0.01, right? Now, essentially what that means is now you're going to add to this 2 more ions, Na plus and Cl minus. Yeah? You've already got H plus and OH minus in that system. Now you're going to add Na plus, which is sodium, and Cl minus. Now, where do these go? Well, because you have a buildup of OH minuses here, it's going to attract, you're going to have all these OH minuses which are not connected to anything. You've got a liquid in there, it's got loads of OH minuses, it's going to attract one of these. Which one is it going to attract? Is it going to attract a negative or a positive? Think again. OH minus is negative, it's going to attract the opposite, it's going to attract positive. So what you're going to get on this side is NaOH. And on this side, you're going to get Cl minus. So do you see now why you're going to rack this up to 9.5 is now going to become 11.5, and this 4.5 is going to become 2.5. Can you see now why the 2.5 smells of what? Smells of chlorine, isn't it? Yeah? Because what's happened is that the Cl is merging with the protons to form hydrochloric acid. That is what is your pH 2.5. It's basically hydrochloric acid, or a weak hydrochloric acid. Right? This sodium hydroxide is pH 11.5. Sodium hydroxide, ladies and gentlemen, is also known as oven cleaner. That's the stuff that you use to clean the fat inside of the oven. Do you see now why pH 11.5 does what to sesame seed oil? Emulsifies it. Just like how oven cleaner works. So that's why when you add the enhancer, you're getting a strong alkali which will do that job. Yes? Does that all make sense now? You see that how it all works, how the chemistry works. The sodium hydroxide is coming out through the, well, will come out at the top, wouldn't it? Which is the strong Kangen water, the strong Kangen 11.5 pH. And the acidic water is going to come out at the bottom. That's the one that smells like you've been to the swimming pool. Yeah, hydrochloric bleach, exactly, yeah. So that's the stuff. So that's the difference. And obviously, you know about all the benefits of that. We saw a table earlier on about how the effect it has on bacteria and viruses, which is very good. So, yeah, so that's the chemistry behind the electrolysis process. I hope that clears that up. So that's ORP, that's electrolysis. Now, the last thing we've got to talk about is microcluster. Yes? Now, what is microcluster? What is it? I'll tell you what microcluster is. Microcluster is another misnomer, because we like doing that with you guys. Yeah, pH, microcluster. Microcluster is basically a way of trying to describe the property that the water has in being able to penetrate and get into places where you wouldn't ordinarily expect it to. Yes? Now, how does it do it? Nobody really understands. If you go up to a scientist and say to him, this water is very, very small and this water is very, very big, he's going to tell you where to go. Yeah? Because there is simply no way of quantifying how, you know, you get all these people who bring these big beads and small beads, and, you know, they got 50,000 beads in a beaker and 10,000 in the other one. They say, oh, this one's smaller and this one's bigger. Very, very good idea of explaining it. But what it actually does, it uses a very careful sort of way of basically vibrations, I think is what it is. It looks at the vibrations of the actual atoms and its ability to penetrate. But I think the key thing is active hydrogen, because hydrogen is the gas. We did an experiment where we took a bag, plastic bag of water, which contained just normal tap water. Now you're going to tell me what this does. When I measured the ORP, what was the ORP of the tap water? Was it positive or negative? How much? About 200 to 300, yeah? Now, what we did was we inserted that in a beaker full of pH 9.5, which had an ORP of what? Positive or negative? Or negative 600, actually, because we did it with an SD501. We've got negative 600 ORP in the pH 9.5. We had a plus 200. Then we went away. We made a cup of tea. And then we came back. And when we measured the ORP in here, what was the ORP? Positive or negative? It was negative. So somehow, this water has entered through this plastic bag into there and caused this to go up. What is that? Electrons? Active hydrogen. Active hydrogen is a gas. Gas gets across the... It's exactly the same thing as... Basically what it is, it's a semi-permeable... Well, Normally, if you had, for example, salt solution outside, would you expect the salt to get inside the water through the plastic bag? No, can't do it. But the plastic bag, for some reason, that active hydrogen managed to get across that gap. So that is what is actually doing it. It's the active hydrogen that's, because remember, look how small it is. Well, we had the periodic table up. Small, it's only what? Atomic number of 2 molecular hydrogens, 1 and 1. And that is so tiny, it managed to get across that plastic into the other. So that's essentially what's happening. And through that, because the other thing is, when you measure the volume in here and the volume in here, would you expect this volume to go up? It doesn't. The volume stays the same. So something is getting out of the tap, something is getting out from the pH 9.5 into the bag. So it's the active hydrogen. It's the active hydrogen that's getting in there and causing the ORP to go more negative. So that is basically how this is working. Now, you all know about Mr. Peter Agre. Yes? He's the guy that won the Nobel Prize in 2003 for discovering aquaporins in the cell. So, I think we're done now with the Kangen because we know we've talked about pH, we've talked about alkalization, and we've talked about microcluster to a certain extent. What we now need to do is we now need to look. So we've talked about molecular hydrogen. Now we're going to talk about molecular hydrogen. Now we're going to talk about the cellular aspect. Now, this is where we go back to. We studied chemistry. Now we're going to do some biology. So we've got the cell. What is the most important part of a cell? Say again? The nucleus? The membrane, yeah. It's who you let in and who you let out. It's the bouncers at the door. Yeah? That is very important. And this is made of a lipid bilayer. Now, what is a lipid bilayer? A lipid bilayer is basically you have fats and you have proteins. On the inside of the cell, you have liquid. And on the outside of the cell, you have liquid. And you have these bilayer where the fat is on the outside and on the inside. And the proteins are sort of near the center. Well, actually, the protein actually can go right across. But essentially what it does, it has a water-liking side and it has a fat-liking side. So most of the fats are all in the center and all the water bits from the outside. But anyway, this is a lipid bilayer. It lets things in. In the cell, you have your nucleus. In the nucleus, you have your DNA, which, ladies and gentlemen, is also an area where you can get free radical damage. If you get free radicals damaging the DNA, you're upsetting the genetic code. Now, what is the purpose of a cell? What does a cell do? What does a cell do? Yeah, it duplicates, but the other thing it does, it's a factory. It's a factory for making things. And how do we know that? Because in here you've got the genetic code. Then you have, this is DNA. Then on the outside of the cell you have these wonderful things here, which are called what? Mitochondria. Yeah, and this is the energy producing cells. Or basically what it is they're organelles which are in the cell which produce energy. And the currency of energy in the body is known as ATP, adenosine triphosphate. That's the energy. If you've got enough of those, that's how you're able to walk around, move around. Yes? ATP. So these mitochondria produce ATP, and this here is your nucleus. Now, this is not the cross-section of an orange. Okay? I want to make that clear. So what you have is you have your DNA, and then you have the messenger RNA which comes out, and then you have these things called Golgi apparatus. And this goes here, and it produces proteins. It takes amino acids, and it joins it together, and then it ships that protein out of the cell. That's basically what it is. Yes? So it's like a sort of power plant. It's almost like a car manufacturing factory. Yeah? It's a factory producing cars, and the cars get shipped out. That's what the cell is. Producing all these wonderful proteins which go and circulate around. Now, what are the 4 side effects of Kangen water? The 4 side effects. Come on, man. You guys, you've seen Demikale's thing, haven't you? Yes? Right. So the first side effect is you get a headache. Yeah? People who are not used to drinking Kangen, first thing that they get, not everybody, first thing that they get is they get a headache. Usually lasts maybe the evening and then it goes off. Now, why do they get a headache? We're told that it's called healing crisis, which is true. Because what it is that in your body you have water. And we'll come on to that in a second because I need to explain to you how that works. But essentially, your cells are not used to it. It's not used to that degree of alkalinity. Somebody in their right mind came up with this idea that you should all drink tap water, which has a pH of 7. And we've been doing that ever since. Yes? Now, our body is used to that. Suddenly, we get 9.5 pH thrown into the system. You start drinking it, and it gets into the blood, and we know that it has this microcluster capabilities. It can penetrate every single cell. As a matter of fact, as soon as that water touches your lips, it's getting absorbed straight into the system. It goes through the cell, into the blood, up in, across the blood-brain barrier, into the brain, into the cell of the brain, yes? And then your brain then says, what the hell is happening here? All this PAR, it's completely overloaded. And it starts firing off all of these signals, and you get a headache. And then what happens is it starts to acclimatize, everything gets back to normal, and then your body gets used to it. So that's the first side effect, yes? The second side effect is what? You go to the toilet. You end up peeing more, yes? Because obviously if all this fluid is getting into the system, it's got to come out sometime. And this is why half of you will end up going to the toilet halfway through this movie. That's if you've been drinking all day, but anyway. So that's the second side effect. The third side effect is you start to sleep better. Now, why do you sleep better? Because inside the brain, you're producing something called melatonin. When the melatonin levels go up, you sleep better. And the last side effect is your energy levels start to go skyrocketing through the day. These are usually slightly later side effects. And the serotonin level goes up because your body's producing more serotonin. Now, why is it doing that? Why is it producing more? This is a question you're going to get asked. Why? Well, this is your cell. Inside this cell, you have liquid, you have this, you have all of these organelles. Think about it like a car factory plant. If I want to increase productivity in a car plant, what do I need to do? You've got to have better facilities. You've got to have more workers. You've got to make sure you feed the workers. You don't want workers who end up collapsing on the floor and you kick them out. Yeah? You need to make sure that they have the proper working environment. You need to make sure you have proper materials so they can build the car. You need to make sure that you have enough funding. Yeah? All of these things become important. So exactly the same thing that's happening here. What you need is you need all of these cells to have all of the things so that it can produce. You need proteins, you need nutrition, and the other two things you need is temperature and pH. Yeah? So for example, if you're working in a power plant or working in a car factory plant, if you reduce the temperature in the room to minus 20 degrees, are those workers going to work effectively? No. So you're going to make sure that, and if you heat it up too high and it gets really boiling hot, are they going to work effectively? No. So you've got to make sure they have air conditioning so those workers can work properly. So temperature is important. Yeah? The other thing that's important is pH. Yeah? So if you have the optimum pH in this cell, it's going to produce more. So what I'm saying is that those people who do not sleep properly, yes, they probably aren't producing enough melatonin. And it's possible that because their pH environment is too high, it should be slightly lower. And how are we going to achieve a slightly lower pH? By drinking Kangen 9.5. Because you're going to optimize the pH in the cell so that it can do the job that it was meant to do, which is to produce those proteins and those melatonin in the cells, and so that you can sleep properly, serotonin, so that you have high energy when you're working through the day, during the day. So this is what the cellular environment. So it's important you understand this, because that's how you're going to understand how those side effects come into play. Yeah? So, the next thing we need to talk about is, for example, these conditions. So you have things like diabetes, you have high blood pressure, we had somebody who had SLE, we have cancer, all of these conditions. Now, I'm not going to go through every single one of them, but as I said before, if we can go down to the molecular and cellular level, you might be able to answer those questions for yourself. We've already discovered that in order for a cell to work properly, it has to have the optimum environment to do it in. So we've established that the temperature is important. pH is important. Now, you've all heard of a guy called Otto Heinrich Warburg, yes? And what did he say about cancer cells? Acidic environment and lack of oxygen, exactly. So, in order to try to counteract that, you want to try and provide an environment which is alkaline and has antioxidant properties or oxidation. And this is where Kangen water 11.5 comes in. Because the pH 11.5 is going to be the most highest pH you can get out of the cell, out of the machine. And by producing that high pH water, now, another question you're going to get asked, do I use it with enhancer or without enhancer? Yeah? Common question? Right. The answer to that question is that what is the difference between enhancer and not using the enhancer? What pH level are we talking about? Negligible, isn't it? It's about 1. But it's still quite important because it's a logarithmic scale. So it's probably a factor of 100 or 1,000 between pH 11.5 and say 10.5. 9.5 is what you get out of the machine when you press the 9.5 button. But when you press the button which says strong acidic water, the pH you're getting is slightly higher without the enhancer. When you stick the enhancer in, I've already explained to you what happens. The sodium hypochlorite solution separates out, sodium joins the hydroxyl, produces NaOH, which makes that water even more higher pH, 11.5. Yeah? So that's how you're getting that. So what you're trying to do essentially is you're trying to produce a cellular environment which contains less protons. Now this comes on to what's known as the dilutional effect. To explain the dilutional effect, we have to go to the next diagram, which is to understand how much water there is in a 70-kilogram male. You have a 70-kilogram male. How many liters of water inside a 70-kilogram male? 3.5 liters. Any advance on 3.5? 70 liters? 49? Okay. So the answer is 45. 45 liters of water in a 70-kilogram male. Now the guy who came up with 3.5 is probably getting mixed up with the volume of blood in the body. And how much volume of blood is there in the body? How many pints? 8 pints or 5 liters. Yeah? So 5 liters of liquid is in blood. What's my next question going to be? What's my next question going to be? My next question is where the hell is the other 40? Yes? We've got 5 liters of blood. Where's the other 40? No. 40 plus 5 makes 45, yeah? Have I not written it big enough? So 45 liters of water, 5 liters in the blood. Where's the other 40? Right, so you've got 25 in the intracellular space. How many cells are there in the body? Start counting. I want an answer by this evening. Okay. So there's between 37 and 70 trillion cells in the body. If you take every single one of those cells and take all the liquid out of all of them, yes, you get about 25 liters in total. So if you have 25 liters intracellular, where's the rest? Extracellular. Yeah? Remember I drew that diagram of the cell? Yeah? You got liquid in the cell, and you got liquid outside the cell. Inside the cell, 25, outside 15. So that's how the distribution of water is in the body. Dr. Michael will talk about bones and all these other things which makes up the rest. He's talking about 72% of the body being water. But if you equate it into volume, this is important. Can everybody see why this is an important diagram? Because when you drink your Kangen water, your bottle, can you see how the volume is going to separate how much of that is going to be intracellular? Is it going to be more or less than in the blood? More of it is going to go to the cells. Yeah? Because 25 liters is intracellular. Yeah? So if you divide this up in proportions, the majority of the water is going to go intracellular. Some of it is going to be extracellular, and the least is going to be in the blood. Yeah? That's how the water is going to distribute, because we also know that this particular Kangen water has what other property? Microcluster. So it means that it can get through all of those barriers. Remember, the fluid in the blood is contained within a closed circuit of arteries, veins, capillaries, venules, and the chamber of the heart. That's where all the volume of blood is. Yeah? So that's one closed circuit. So you're going to get water getting into that. Then you've got water in the cells, which are surrounded by a cellular membrane. And then you've got fluid outside the cells, which are within a network of cells which are encasing that extracellular space. So straight away, you can see you have three different compartments. You've got the fluid compartment in the blood, you've got fluid compartment in the cell, and you've got fluid compartment in the extracellular space. This water has to try to penetrate all of that. And as we know, Kangen water has the capability of doing that. So it's going to separate out like that. Can you see now why majority of that water is going to get into the intracellular space? That's why in 2 hours' time, or 1.5, you're all going to end up in the toilet, because it all has to come back out. Now, if you have a system like that, can you see why detoxification is going to be very important? Because if that water can penetrate the intracellular, that water can get into the cell, and it can then come out, essentially you have a system, you have the best transportation system possible at your disposal by drinking this water. Because this water is going to get into the system, it's going to take out all of the carbon dioxide and all the various different excretants. Yes? You've seen the diagram where Dr. Michaels explains about how the cell contracts and expands, and then by contracting and expanding, it's releasing some of those toxins. And you get nutrients going in. So the water gets in, it changes the pH environment within the cell. So now we're covering Otto Heinrich Warburg's point, which is that you're trying to alkalinize the inside. Now, what you're actually doing is you're going to be reducing the pH. So the more and more of this Kangen water that you drink, day by day, I mean, how much water are you going to drink in a day? It varies. The allopathic guideline is men should be drinking at least 2.5 liters of water a day, and women should be drinking 2 liters a day. But that's a guesstimate. What you should actually do is take your volume in kilograms, multiply it by 50. So if you're 50 kilograms and you multiply by 50, you should be drinking at least 2.5 liters of water a day. Yeah? If you're 100 kilos, multiply that by 50, you should be drinking about 5 liters a day, or about a gallon. American gallon, which is just under 5, so about 5 liters. But if you have 45 liters of water in your body, how long is it going to take before you completely replace all that water if you're drinking 5 liters a day? Take about 9 days. Yeah? If you're drinking half of that, it'll take you about 2 weeks. Well, 18 days, maybe coming up to 3 weeks before you actually replace all of that water. Yeah? So this is essentially what you're trying to aim for, to try and get all of that water in and detoxify the body. So after 3 weeks of drinking Kangen water at 2 liters a day, you can rest assured that what you're doing is you're replacing all of that. You're detoxifying the body. So that's one of the other main benefits. So can you see now, as we go through this, explaining at the cellular and molecular level, we've already covered loads of properties here. One property we've already talked about, detoxification. Another property we've talked about is trying to get the pH to be slightly lower and create an environment in which cancer cells cannot grow. Because Otto Heinrich Warburg said that if you can get the pH... Now, before we talk about what Otto Heinrich Warburg said, what's the normal pH of blood? So the pH of blood is normally between 7.35 and 7.45. Anything outside of that range, the body goes into shock. Yeah? This is where we start talking about the slide which we saw very at the beginning, where we're talking about alkalinizing water chemically. What that does, it alkalizes the blood. Now, there's another thing I want to clear up. When people talk about alkalizing the body, are we talking about alkalizing the cells, or are we talking about alkalizing the blood? See, again, mixed reactions, because doctors and nutritional therapists alike are not very good at explaining this. This is why they need that diagram with the water, the blood, the cells, the intracellular space, extracellular space. What you're actually trying to do is you're trying to alkalinize the cells in the body. Yeah? That's what you're trying to aim to do. But that also involves blood, because blood contains cells. It's not just the blood, it's the whole system you're trying to alkalinize. Now, if you try to alkalinize the blood alone, the problem you're going to have is you're going to push that pH beyond 7.45. Is that good or bad? Yeah. So that means you go into something called metabolic alkalosis. Yes? Now, the two organs which are responsible for maintaining the pH within the body is the lungs and the kidney. When you breathe in oxygen and you breathe out what? Carbon dioxide. And carbon dioxide is the acidic component. In order to understand that, you need to look at this equation. H2O plus CO2 goes to H2CO3, and on this side it goes to H plus HCO3 minus. Now you're all looking at that and thinking, what the hell has he drawn there? Well, let me explain. H2O is water, CO2 is carbon dioxide, which is a gas. If you join these together, you get hydrogen carbonate. On this side of the equation, you have protons, our friend the proton, and a bicarbonate ion, HCO3 minus. Yes? This here decreases the pH, making it more acid. Right? So if you have a lot of this, it's going to drive the reaction that way. Actually, you know what? I've drawn this wrong. This should be here. And this should be here. Yeah, that's right. Sorry. So H2CO3 is in the middle. It can go either that way or this way. If it goes that way, you have the protons and the HCO3 minus. If you increase this, it's going to drive the reaction this way and cause this to go up. If you blow this off, when you breathe out through your lungs, you're going to reduce the acidity. So, for example, when you take patients, for example, who have a low pH, so for example, we've already established that the normal blood pH is between 7.35 and 7.45. I have seen patients come into the A&E department with pHs of 6.9. And 6.9 is very, very ill. These patients are patients who have what's known as diabetic ketoacidosis. So basically what it means is they've got a lot of acid in their body. Yes? So by having a lot of acid in their body, you need to try to reduce it, and this is why the body goes into shock. Yeah? So what happens is those patients who have diabetic ketoacidosis, they're breathing very high. They're like that. They're hyperventilating because they're blowing off CO2, carbon dioxide, to try and get their body to reduce the acidity. So this is how the body works. So this system here is how the body controls that. So the blood pH is trying to maintain within this 7.35 to 7.45. Yeah? And anything outside of that is going to basically not be compatible with life. So what Otto Heinrich Warburg said is that if you can get a pH of 7.41 or above, cancer cells cannot grow. Can you see now why, by drinking Kangen 9.5 or 11.5, that might help to would help to increase the pH of the cells? Yeah? Now, it's not going to happen where you just drink the water and suddenly all the cells then become 11.5. It doesn't work like that, because it's called a dilutional effect. I always equate this to taking a drop of my blood. If I take a drop of my blood and drop it in the ocean, does the ocean go red? It doesn't, but it goes slightly red. What degree of redness? We don't know. It's very, very, very minute. It's the same with 11.5 pH. You add that to the water, You add that to the body, it's going to increase the pH only very slightly, but it may just be slight enough to push that pH above 7.41 and create an environment in all the cells in the body to be at a level where cancer cells cannot grow. Did you see now why that pH is important? Yes? Excellent. So, that's about the blood story. We've talked about Otto Heinrich Warburg, about trying to increase the pH, 11.5. I think that's it. I think I've covered it all. Thank you very much. Assalamu alaikum.